Good day, everyone. And once again, we are back together. And of course, we're going to be continuing with the subject of Surds. So if you haven't subscribed, just please make sure that you're part of the family. And of course, you can get in touch with us. Our email address is info@mlungisinkosi.co.za for any value added services that you might need in terms of maths and science. Now, the last time that we're looking at surds, we were looking at the multiplication and the division of surds. But today I want us to look at the addition and the subtraction of surds. All right, so let me just give you a couple of rules, okay? So let's talk about the first rule. So rule number one that we're going to be looking at. So if we are adding surds, right, our obviously non-rational roots. In this case, if we had, let's just make an example, right? A root of the C root of A, right? Plus another, say for argument's sake, C root of A, right? Okay, now if I'm going to add these two, by the way, we just need to be mindful that when we add, it has to be surds that are exactly the same, right? So for instance, we cannot add surds that are not necessarily the same. So in this case, what this would give me would be 2, right? It would be almost the same as saying 2x plus, x plus x, right? So this would be 2, the cth root of A, okay? The C root of A. Now let me make an example on this, right? So say for argument's sake, I've got, cube root of 3 plus, let's say 2 cube root of 3, okay? Right, now in this case, because these are exactly the same roots, right? So it's cube roots on both of them. And in this case, so I can add those two. And by the way, even the number is the same inside the surd or inside the root. So in this case, this can be 3, the cube root of 3, right? So if I took the square root of, say, 5 plus 4, the square root of 5, again, both of them are square roots, okay? So we know square root means there's a 2 there. We don't always write that 2. So in this case, all I can simply say is that, well, I've got 1 square root 5 plus 4 square root 5. So what will be our final answer? So that will be 1 plus 4 will give us 5. So that will be 5 root of 5, okay? So the same works for subtraction, right? So if I were to get a root, okay, say we get the 6th root of 2, okay, let's just say, we subtract 3, the 6th root of 2, okay? So in this case, in fact, let me just maybe not use 3, let me use 4 instead, right? So if I've got the 6th root. Now remember, there is an invisible 1 here, right? In this case, so this would be 1, the 6th root of 2, and minus 4, the 6th root of 2. Right, now in this case, all I'm just simply going to do is say, well, 1 subtract 4, in this case, that would give me negative 3, right? The 6th root of 2, okay? So that is how it works in terms of roots. Now, we're going to take some examples in a little while, right? But what I just want you to be mindful of, ladies and gents, I'm giving this advice just for free, just for you, right? Whenever you're working with roots, say, just for argument's sake, if I give you a root, let's just say the root of 98. Yeah, I think this would be a nice one. Right, if I say the root of 98, now you must find a way to break the number, if it's an irrational number, you break it down into a prime number and a perfect square. That always works wonders, right? Prime number and a perfect square. So think about it. If I take 98, what prime number can I multiply by with a perfect square to get 98? Well, think about it. So in this case, that would be 49 multiplied by 2. Why am I choosing 49? Because, well, 49 is a perfect square and 2 is a prime number, right? So in this case, the square root of 49, now we are using the multiplication rule. In this case, we said if we are multiplying, this is the same as saying square root of 49 multiplied by the square root of 2, right? So therefore, square root of 49, that would give me 7, okay, multiplied by root 2. So my final answer would be 7 root 2. Well, you can do the same with square root of 50. Okay, if I give you square root of 50, how would you simplify the set? Well, you would say, well, the number that gives us 50, in this case, you can say that's 25 multiplied by the square root of 2, multiplied by 2. So 25 times 2 gives us 50, right? And so this would give us 5 the root of 2, right? So we can simplify it that way, given any root that we are given. All right, so we will look at these even more further as we go through examples. Let's go through our examples now. All right, so let's check out the following examples. Okay, they say to us, simplify without the use of a calculator. Leave your answer in set form. Now, guys, I know some of you are used to, cheating and, using a calculator. Of course, the examiner would be able to tell when you've used a calculator. And the point of it is that there should be procedures that you apply. We'll look at the steps that would enable you to get to the answer without using a calculator. Okay, right. So let's try it and stick to those rules. I said to you, try to break the numbers down into prime numbers and perfect squares, right? That usually works with sets. Now, let's go for the first one. 48, right? So if you think about it, if I said 48 divided by 2, that would give me 24, right? But remember, 24 is not a perfect square. 2 is a prime number, but 24 is not a perfect square. But in this case, what can I convert 48 to? So in this case, if I said 48 divided by 3, right? Definitely that would give me 16, right? 3 is a perfect square, and 3 is a prime number, and 16 is a perfect square. Okay, right. So in this case, I'm going to say, well, let's convert that into 16 multiplied by 3. And let's go for 27. Think about it. In this case, I would have 9 multiplied by 3. 9 is a perfect square, and 3 is a prime number, isn't it? So that would be 9 multiplied by 3. Right, of course, this takes a little bit of practice and getting used to, okay? Just knowing your multiplication table as well as your prime numbers as well. Right, so in this case, square root of 16 multiplied by square root of 3. If you watched our video on the multiplication of surds, you know that we can actually break it down, right? So if we've got two surds that are exactly the same, we can actually just put them together under one surd, right? So that would be square root of 16 multiplied by root 3 is root 9 multiplied by root 3. Of course, square root of 16, that gives us 4. So this would be 4 root 3 plus 3 root 3. And so what does that give us? Okay, we know that we said that we can actually add them if we've got the same root. So that will give us 4 plus 3. That will give us 7 root 3. And that will be our final answer, right? Okay, so let's go on to the next one. We've got root of 50. Okay, so what can we break that down to? We can say, well, square root of 50, think about it. So that will be 25 times 2, right? So, and in this case, some of the surds can actually give you a clue. I can see we can't actually simplify this any further. So it means that we can actually, we need to have a root 2 somewhere, right? So that would be 25 times 2. That's a perfect square, and that is a prime number, right? Plus root of 2 divided by square root of 18. That will be 9 times 2. Okay, the root of 9 times 2. And in this case, what do we have? We've got 5 root of 2 plus root 2 divided by 3 root of 2. Now, in this case, if I want to simplify this, now remember we said we can add. We've got the roots that are the same there, square roots that are the same, okay, or rather, yeah, the roots that are the same, I did say. So 6, so that will be 5 plus 1, that would be 6 root of 2 divided by 3 root of 2. And of course, you can see how those can cancel out, and 6 divided by 3 would give us 2, and that will be our final answer, right? Okay, let's go on to the next one. We've got a root of 63. Now, that may not be very obvious, okay, but how do we now, convert that? Okay, so if I said divided by 2, definitely that wouldn't work, right? If I said 63 divided by 2, that wouldn't work, okay, even though that's a prime number. But if I said 63 divided by 3, let's see if that can give us a perfect square. Divide by 3, that gives us 21. That's not a perfect square, right? But I can almost see that we're looking at the ballpark of 7, because when I look at 28 there, right, I know that 4 multiplied by 7 would give me a 28, right? So would it be possible for me to use 7 then? 63 divided by 7. 7 is a prime number. That gives me 9. Can you see? So it means I can now break this down to 9 multiplied by 7, 9 being a perfect square and 7 being a prime number. And 28, that would give me 4 multiplied by 7. Okay, and in this case, we've got divided by, okay, we said 63 is 9 multiplied by 7. Of course, we're taking the square root of that. Okay, so in this case, we've got, okay, square root of 9 is 3, root of 7. Okay, I hope you've got it by now that you can take square root 9 times square root 7, and square root 9 is 3, plus square root of 4 is 2, multiplied by root 7, divided by, okay, that would be 3 root of 7. Now let's try and simplify that. Okay, so we've got 3 plus 2 root 7, so that would give us 5 root of 7 divided by 3 root of 7. And again, we see how that can cancel each other, and our final answer would be 5 over 3. All right, I hope that makes sense, ladies and gents. Right, let's go on to the next one. Okay, so the next one, we've got 50 multiplied by x squared. Okay, so remember, we're going to take square root of 50 multiplied by square root of x squared plus square root of 18 multiplied by the square root of x to the exponent 10 divided by, underneath we've got square root of 32 multiplied by square root of x to the exponent 10. Now, let's try and deal with it. So, square root of 50, I'm sure you've got it by now. You've got 25 times 2. That's a perfect square and a prime number, right? Now, let's write this in exponent form in this case. So, that will give us x 2, remember this one becomes the numerator, and in this case the surd, okay, the root of the surd in this case becomes the denominator. So remember, when we've got a square root, there's a 2 there, even though we don't write it all the time. So this would be 2 over 2, right? So keep that in mind. Plus square root of 18. I'm sure you saw it on the last one. We have 9 multiplied by 2, okay? And in this case, that becomes, now remember, this one becomes the numerator, that's 10. And the root, we said we've got a 2 there, so that becomes divided by 2, okay? If you don't understand this, it means you haven't watched our last video on surds. Please do yourself a favor and do that. Right, so we've got, in this case, 16 multiplied by 2, okay? And we've got x, I'm sure you've got it now, x, that's 10 over 2. Right, now let's simplify this further. So that would be 5 root 2 times x plus 3 root 2, okay, times x, 10 over 2, that's 5, divided by, that's going to be 4 root of 2 x to the exponent 5. All right, I'm sure we can simplify this further. Of course, every term has got a root 2 in it, and it's got an x in it at least. So that would be, if I take out root 2 at the top times the x, the common factor there, that would give me 5 plus, okay, that would be 3 x to the exponent 4. Okay, I hope you've got that, right? Because x times x to the power 1 multiplied by x to the power 4 will give us x to the power 5, right? And then at the bottom we've got 4 root of 2 x to the exponent 5. Now I'm sure you can actually see how we are going to cancel out root 2 and root 2 over there, right? Now remember, when we apply the exponential law, okay, so that would be, okay, that's x to the exponent 1 divided by x exponent 5, right? In this case, what happens? If I take this 1 to the bottom, it becomes a minus 1. Okay, so I can remove this and make that minus 1 there, right? And what do I have? In this case, I would be left with 5. Okay, let me get this guy out of the way. 5 plus 3 x to the exponent 4 divided by 4. That's 5 minus 1. In this case, the bases are the same. The exponents, will subtract or add each other. So that's 5 minus 1, that would give us 4. And I will leave it like that in its most simplest form. Right, let's go on to the last one, okay? So root of 128, okay? If we think about it, that would be 64 times 2, okay? Minus, in this case, I've got 100 multiplied by 2, okay? That's the experience in me talking, because I know 100 is a perfect square. And 98 again, I've got 49 times 2. Okay, so in this case, all of them perfect squares, 49, 100, and 64. So this would be 8 root 2 minus square root of 100 is 10 root 2 minus 7 root 2. Square root of 49 is 7. So in this case, I've got 8 minus 10, which would be negative 3 root 2. Minus 2 rather, root 2. And minus 7 root 2. So all of that would give me minus 9 root of 2. That would be our final answer. Okay, right. So ladies and gents, I want you to perhaps try this out on your own. Okay, So this would be your example, okay, or your homework, or I don't know what you want to call it. So if we take 2 root of 8 minus 4 root of 32 plus 3 root of 50. Please simplify without the use of a calculator. And the next episode, or in the next series, we are going to be looking at rationalizing surds. All right, so please look out for that. Otherwise, from me for now, I'll see you guys next time. Please don't forget to subscribe and like and comment. Leave a very nice comment. I'll see you guys next time. Sharp, sharp.